might go down to 3.
Okay, let's get started. So we're gonna start with section 6.1. And what we're gonna be doing here is solving something called a system of equations. So this is, maybe you could write one out and just see what does this actually mean. So for example, say something that we want to solve is, this would look like this: x plus y is equal to 2. And we also have 3x plus y is equal to 0. So we have these two equations and we want to solve them. And so what that actually means is, well, these two equations are lines. For example, we can turn all these into y equals mx plus b form. Like on this top one, we can just subtract the x over. We get y is equal to minus x plus 2. We know that's just a line. We can graph that. And the bottom, we subtract the 3x over. We just get y is equal to minus 3x. So both these two things are just lines. So let's see what happens if we were to graph these two lines. Over here. So graphing the y equals minus x plus 2. To graph a line, we only need 2 points. Let's put this over here. Let's make like a little xy table. So x, and then y, and this will be for the top line, the minus x plus 2. If we plug x to be 0, we get 2. If we plug x to be, say if we plug in 2, we get 0. So we have those 2 points on a line at 0, 2, and at 2, 0. This is the point, let's draw that. This was the line y is equal to minus x plus 2. Now let's make another xy table for the other line. If we plug x to be in 0 here, we get 0. Say if we plug x to be 1, we get minus 3. So we have those 2 points. We have the point 0, 0, and 1 minus 3. 1 minus 3. Let's make this line a little bit better. Let me draw them. Okay, here's this line. So notice that, okay, this line down here, this was, so y is equal to minus 3x. So, we originally start with this, which is called systems of equations, which is actually just a couple of lines. And we notice that if we draw those lines intersect. So those lines intersect at this point right here. And this point, is an x, it has an x coordinate, it has a y coordinate. And that's going to be the answer to this problem. So when we're given something like this, we want to know, okay, where do those lines intersect? And so say if we're just going to do this graphically, but we can't really know for sure, like what are these numbers here? But this red dot is where that would be the solution of this equation. It's where these lines intersect. So that's basically what this problem means. But there's ways to find this where we don't need to graph. Graphing is just kind of seeing what's going on. So let's do the same problem again. Let's write this down. Down here we have x plus y is equal to 2. And 3x plus y is equal to 0. And so then there's a couple of ways we could do to figure out how do we find what is x and what is y. So what is x and what is y, meaning that this point right here, this is the point that we want to find. where the two lines intersect. And so this first way, this is going to be called the substitution method. So all we do here is we pick an equation. Let's number this just so we can have some references. This is equation 1, and this is equation 2. So we just pick an equation, then we pick a variable to solve for. So for example, let's say if we just pick equation 1 and we want to solve for variable, the first variable, the x variable. So all we have to do is we pick an equation. Let's just pick equation 1. X plus y is equal to 2. Now let's just choose any variable to solve for. We can either solve for x or solve for y. Let's just solve for x. So we could subtract y to the other side. And so we get this. We get x is equal to 2 minus y. Then once we do that, we're going to plug this into our other equation. So notice we started with equation 1. And now what we're going to do is we're going to plug this into equation 2. So what's equation 2? Equation 2 is 3x plus y is equal to 0. But now we know that x is equal to this, 2 minus y. So we're going to plug that in for x right here. So doing that, we get 3, 2 minus y, plus y is equal to 0. All we did is replace this x with this piece right here. All right, so then we get 6 minus 3y plus y is equal to 0. Then we can get, so minus 2y, we can subtract the 6 over. Then we get y is equal to 3. All right, so we found what y is. Now to find x, well, we could just plug this y into either equation 1 or 2. So we have these two equations to choose from. Let's just plug y into either one of them. Let's just choose the first one. Now let's plug this into equation 1. Again, we can plug this into equation 1 or 2. It doesn't matter which one. But equation 1 says x plus y is equal to 2. So if we plug y is equal to 3 into here, we're just going to get x plus 3 is equal to 2. So that means x is equal to minus 1. So we go back up here, and then we can see that this point is actually minus 1, 3. So we can replace that, minus 1, 3. And so this is the substitution method. You pick an equation, you solve for the variable, and you substitute it into the other equation. The other way we could do this is called the elimination method. So let's do that same problem again. X plus y is equal to 2. 3x plus y is equal to 0. So for the elimination method, what we're going to do is we want to pick in the variable to eliminate by adding and subtracting these equations together. So what we mean by that is we'll notice that this top equation has a y and this bottom equation has a y. So if we were to subtract these two equations, the y would go away. So if we just subtract these two equations, so we're going to get x minus 3x, which is minus 2x, y minus y, which is 0, and 2 minus 0, which is 2. So this just gives us x is equal to minus 1. Now what we can do is just plug this into any of the equations. Let's just choose the top one. So we have x plus y is equal to 2. If we plug x equals minus 1 in here, we get minus 1 plus y is equal to 2. So adding the minus 1 over, we get y is equal to 3. And then we're done. So if you notice, elimination is much quicker than substitution. And unless the directions say otherwise, you should always use elimination. Elimination is always the best way to do these problems. But we'll go over both. These are the only two methods that we're going to do, the elimination method and the substitution method. So we'll, so basically so far we've done one example with 3 different methods. This is the graphing way, we have the substitution method, and then here's the elimination method. Now let's do several of the substitution method. Okay, substitution. So this is number 18. 3x minus y is equal to 5. and x plus y is equal to 1/2. So the substitution method, remember, we've got to pick an equation and then solve for a variable. Let's just pick the second equation. So we could, for example, we could take x plus y, which is here's the first equation, here's the second equation. Let's just take our second equation, x plus y is equal to 1/2, and then let's solve for, it doesn't really matter. I don't think anyone's going to make it easier or harder. Let's just solve for y. So doing this, we can get y is equal to minus x plus 1/2. So now what we need to do, we need to plug this into the other equation. So we chose the second equation, so we need to plug this into the first equation. So our first equation, 3x minus y is equal to 5. So what we're going to do now is we're going to take this y and plug it into this equation over here. Okay, so then we're going to get 3x minus x plus 1/2 is equal to 5. So this is 3x plus x minus 1/2 is equal to 5. Okay, so then we have 4x is equal to 5 plus 1/2. So we have 4x is equal to 11 over 2. And then this gives us, so divide by the 4, we have x is equal to 11 over 8. So we found what x is. So now what we have to do is just plug this x into any of the equations above. So we could choose equation number 2, for example. That's just x plus y is equal to 1/2. So now we need to plug this x value into here. So we get 11 over 8 plus y is equal to 1/2. So this tells us that y is equal to 1/2 minus 11 over 8. Which is going to be, so what we have there, 4 minus 11, so minus 7 over 8 is equal to y. So then we have these two answers. We have x is 11 over 8 and y is minus 7 over 8. Okay, how about 22? So 22 says 3x plus 5y is equal to 2, and then 2x minus y is equal to minus 3. So we want to find an equation to solve for. So in this problem, it's going to be the easiest. So we want to, choose an equation and choose a variable to solve for. So the easiest equation to choose to solve for a variable is going to be the second one. We can solve for y the easiest out of all these equations. So let's take the second equation, 2x minus y is equal to minus 3. Now let's solve for y. So all we have to do is add the 3 over to the left and then add the y over to the right. So 2x plus 3 is equal to y. So now what we got to do is we got to take this and plug it into the other equation. So we chose equation 2 to begin with. So now we need to choose equation 3. What we need to do is we have to plug this y into this equation. So we are going to get 3x plus 5. Now y is the same, so we're plugging in y now. So 2x plus 3. That's equal to 2. So we have 3x plus 10x plus 15 is equal to 2. So we have 13x is equal to minus 13. So x is equal to minus 1. So now we take any of these equations, plug in x is equal to minus 1. Let's take that second equation. So we have 2x minus y is equal to minus 3. If we plug x to be minus 1 in here, we're going to get 2 times minus 1 minus y is equal to minus 3. So minus 2, we add that over. So we're going to get minus y is equal to minus 1. So it implies y is equal to 1. Okay. Okay, and so these are our answers. We get x is equal to -1, and then we get y is equal to +1. Okay, I think it's good for substitution. There's a couple examples for that. Let's do a couple examples for elimination. Let's start with 32. So we have 3x plus 4y is equal to -2. And we have minus 3x minus 5y is equal to 1. So notice that, remember, in the elimination method, we want to find a variable to eliminate by adding and subtracting these equations together. In this example, you see how we have a 3x here and a minus 3x here. So if we were to add these two equations together, the x's would cancel. So let's do that. Let's just start by adding these equations. So we have 3x minus 3x, which is 0, 4y plus a negative 5y, which is a minus y, and a -2 plus a 1, which is a -1. So we have minus y is equal to -1. And so that just tells us that y is equal to 1. So now, just like before, we could pick any of our equations. Let's pick just the top equation. 3x plus 4y is equal to -2. Then what we could do is just plug y is equal to 1 into here. So we get 3x plus 4 equal to -2. So we get 3x is equal to -6. X is equal to -2. Okay, next one, 34. So we have x plus 3y is equal to 0, and 20x minus 15y, 20x minus 15y is equal to 75. So we want to use elimination here, but notice how there's nothing that we can just add and subtract quickly to, let's call this 1, let's call this 2. We can't just add or subtract these equations and something's going to cancel. Notice that if we just add or subtract, the 20x and the x aren't going to cancel. Same with this 3y and this minus 15y. So we have to do something else. Notice that what we can do is, well, we can take this second equation and just divide everything by 5. So see, if we take this second equation and divide everything in there by 5, what this means is we're doing so just 1/5 times the second equation. So what that gives us is 4x minus 3y is equal to 75 divided by 15. So now let's see what we have. So we have this new equation. We did this by taking the second equation, dividing it by 5. But so notice that now we're able to combine this one with the first equation. So our first equation was up here at x plus 3y is equal to 0. And this new equation we just came up with, 4x minus 3y is equal to 15. So what we were able to do is we can just take this equation, we're going to divide it by 5, which is this equation right here. But then that allows us to have a 3 here and a -3 here. So we can just add these two equations together, and then those y's are going to cancel. So now if we add these equations together, so we're going to get 5x, the y's cancel, equal to 15, which tells us that x is equal to 3. So now we can choose any of the equations to plug x equals 3, and let's just take the top equation number 1, x plus 3y is equal to 0. Plug x to be 3 in here, we're going to get 3 plus 3y is equal to 0. So 3y is equal to -3, and then y is equal to -1. Okay, how about 36? So what we have for this one is 2x plus 6y is equal to 7. 7, 3x plus 9y is equal to 10. So this would be the first equation. Here's our second equation. So again, the things in front don't match. So we can't just add or subtract this. So we have to do something to make it so we can eliminate a variable. One thing that we notice is that, well, let's do something like this. What if we took one? Notice that if we divide 6 by 2, that becomes 3. And if we divide 9 by 3, that also becomes 3. So we can get the variables or the numbers in front of y to match. So what we can do is we're going to take half of the first equation, so half of equation 1, and then we're also going to take a third of the second equation. So a half of the first equation, so that's 1/2 2x plus 6y is equal to 7. And then we're going to take a third of the second equation. 3x plus 9y is equal to 10. And what this is going to give us is we'll have x plus 3y is equal to 7 over 2. And at the bottom, we're going to have x plus 3y is equal to 10 over 3. Let's make sure I just copied everything down correctly. Okay. So now notice that we have something here that, notice that this is x plus 3y. This is also x plus 3y. What that means is, well, they're the same exact thing. However, this x plus 3y is equal to 7 over 2. This x plus 3y is equal to 10 over 3. 7 over 2 is not the same thing as 10 over 3. So we have the same equation equaling different numbers. So that's going to lead us to a no solution. So another way we can see that this is going to be a no solution is, notice that if now, so our whole goal was to get numbers in front of the one of the variables to match. For example, we did that with the 3's. We have a 3 in front of this y and a 3 in front of this y. So if we were just to subtract these two equations now, well, just so happens we have x minus x, that's going to be 0. 3y plus minus 3, so 3y minus 3y, that's going to be 0. And then we have 7 over 2 minus 10 over 3. So what this is we have 0 is equal to 7 over 2 minus 10 over 3, but that, the right-hand side does not equal 0. So whenever you get a situation like this where you have 0 is equal to a number that's not 0, that's going to mean that we have no solution. So for this particular problem, we have no solution. However, to get a no solution, you still do the same exact techniques as you would as if this was going to have a solution. So nothing changes in that sense. You just end up with a different end setup. Like you have a number down here is equal to 0. Let's see another one. So there's also infinite solutions. I'm trying to find an example that has that. Yeah, so 38. So for this one, what we have is 6x plus 9y is equal to 12. And then 4x plus 6y is equal to 8. So again, we want to use the elimination method. So we have to figure out a way to, how do we manipulate some of these equations to get the variables in front the same? Well, again, look at, here's a 6 here and here's a 4 here. So if we divide 6 by 3, we get 2. And if we divide 4 by 2, we get 2. So let's take this first equation and divide it by 3. So 1/3 of the first equation. And let's take the second equation and divide it by 2. So half of the second equation. So half of the first equation, that's 1/3. 6x plus 9y. In the next one, so 1/2 is so 4x. And so what we get here for the top equation, we're going to get 2x plus 3y is equal to 12. And for the bottom, we're going to get 2x plus 3y. Oh, sorry, not 12. We have 12 divided by 3, which is 4. And on the bottom, so we'll have 2x plus 3y, and then 8 divided by 2, which is 4. So now notice that we have a 2 in front of the x, a 2 in front of the x. So if we subtract these two equations, we have 2x minus 2x, which is 0. 3y minus 3y is 0. And 4 minus 4 is 0. So we get 0 is equal to 0. Did I write? Oh, yeah, no solutions. So whenever we get this situation, 0 is equal to 0, what this tells us is we have infinite solutions. And so whenever we have infinite solutions, there's an extra step that we do. What we want to do is we just pick any of our original equations, because we want to find a way to represent what the solutions could look like. So what we're going to do now doesn't work with no solutions. This is only something that we do for infinite solutions. So let's say we take our first equation, so 6x plus 9y is equal to 12, and we choose a variable to solve for. Let's just solve for x. So if we solve for x, we're going to get 6x is equal to 12 minus 9y. Then we're going to divide the 6 over to the right-hand side, so x is equal to 12 minus 9y over 6. So what this tells us is that whatever y is, x has to be this. So all of our solutions look like this. We have x is going to be 12 minus 9y divided by 6, and y can be whatever it wants to be. So this is one way to represent the solution. All we did here is we happen to solve for x and we get this answer. But say if we wanted, instead of solving for x, we can solve for y. What's going on here? So in this situation right here, we ended up solving for x. So we could also solve for y. So another way to represent an infinite solution. So let's take that same equation. 6x plus 9y is equal to 12. Now let's solve for y. So we get 9y is equal to 12 minus 6x. Divide the 9 over. Y is equal to 12 minus 6x over 9. So another way of representing the solution, this tells us that x can be whatever it wants to be, but y has to be this whole piece over here. So another way that we can write this solution is going to be, so x can be whatever we want it to be, but then y has to be 12 minus 6x over 9. So these two things right here, they mean the same thing even though they look different. So if you have infinite solutions, this is the next step you do. So once you get to the point, if you are doing work and you get 0 is equal to 0, okay, then once you do that, you pick any of your original equations. We just happened to pick equation number 1 right here. But we didn't need to. We could have picked an equation number 2 and done these same steps. And then you pick your equation, you solve for a variable. So if you end up solving for x, your solution will look something along these lines. And if you end up here, see we solve for y, your solution will look something along these lines. All right, let's do another one together. How about 33? So 33 says we have x minus 3y is equal to 2. And 6x plus 5y. 5y is equal to minus 34. So we want to find a variable to eliminate. And at first glance, this one there's not one that just we can do easily. So we're gonna have to do some more like the manipulation that we've been doing the past couple problems. So something that we see is, well, we have a 1 in front of this x and a 6 in front of this x down here. So we could take this first equation and just multiply it by 6. And then we'll have the same number in front of the x's. So let's take 6 and multiply it by our first equation, and then we'll just rewrite our second equation. So doing that, we're going to have 6 times x minus 3y is equal to 2. And then down here, we just have 6x plus 5y is equal to minus 34. So on the top, we'll have 6x minus 18y is equal to 12. And on the bottom, we're going to have 6x plus 5y is equal to minus 34. So now what we can do, we can subtract these two equations. And that's going to get rid of the x because we'll have 6x minus 6x, which is 0, minus 18y minus 5, which is minus 23y, minus 23y. And then over here, we have 12 minus a negative 34. So 12 plus 34, which is 46. So then this tells us we divide the 23 over, or minus 23 over, we get y is equal to minus 2. So y is minus 2. So now what we can do is pick any of the top equations. Let's just pick the first one. X minus 3y is equal to 2. And then we plug y is equal to minus 2 into here. So we get x minus 3 times minus 2 is equal to 2. So x plus 6 is equal to 2. X is equal to minus 4. All right. So then our answers here, we get y is equal to minus 2, and then x is equal to minus 4. Okay, let's move on to the next section. So the only difference with this section is now we're going to add an extra variable in. So this is section 6.2. So let's just do some more examples together. And so in this section, so let's do number 1. What we have here is x plus y plus z is equal to 2. 6x minus 4y plus 5z is equal to 31. And then 5x plus 2y plus 2z equal to 13. So in this section, we're only going to be using elimination method. That's the only method that we can use to solve these ones. So here's just to label these. We got equation 1, equation 2, equation 3. So what we need to do is we got to find ways to, isolate variables. We want to do some elimination type things. And there's really no direct way to do these problems. You kind of have to do a little bit of like careful thinking and work your way through them. So looking at these problems, let's just try to figure out what can we do. Like how can, basically our first goal is we want to combine two of these equations to turn this problem into something like this. What makes this problem appear nice is that all we have are two equations and two unknowns. So our two unknowns are x and y, and we have two equations. And so whenever we have two equations and two unknowns, we can solve. Right now we have three equations and three unknowns, so we can still solve this, but we want to turn this into two equations and two unknowns and then solve for those two unknowns. So what do we mean by that? Well, let's look at equations 1 and equations 2 only right now. So notice that we have a 1 in front of the x on equation 1 and a 6 in front of the x on equation 2. So a way to get those to match, let's do this. Let's take a 6 and multiply it by equation 1. And then just rewrite equation 2 down here. So doing that, we're going to have, so 6 times equation 1, that's going to be 6x plus 6y plus 6z is equal to 12. All I'm doing is 6 multiplied by this equation right here. And then rewriting equation 2, we have 6x minus 4y plus 5z is equal to 31. So now what we can do is let's just subtract these two things. So the 6's go away. We have 6x minus 6x. Then we have 6y minus a negative 4y, so 10y. 6z minus 5z is just z. 12 minus 31 is was that 11? No, 20. So what's 31 minus 10? That's 21. So minus 19. Yeah. Okay, so we have this new equation. This is an equation that just has y's and z's in it. But so we need to come up with one more equation that just has a y and a z, and then we'll just use the techniques from last section. But now look at, so let's take equation number 3 and equation number 1. So again, we have a 1 in front of the x right here and a 5 right here. So what we can do is let's just take, to make sure that we get a 5 in front of the x on the first equation, let's do 5 times the first equation. And then we'll take our third equation. So 5 times the first equation, what we get here is now we're going to have 5x plus 5y plus 5z is equal to 2, or sorry, equal to 10. And then this equation number 3, 5x plus 2y plus 2z is equal to 13. And now let's subtract these two equations. So those 5x's go away. So now we have 5y minus 2y is 3y. 5z minus 2z is 3z. And 10 minus 13 is minus 3. So now we have two equations. We have this equation right here and this equation right here that only have y's and z's. So let's just take those two equations and now let's solve this system. So we can solve for x or y and z now. So now let's just solve this problem just like it was just like how we did last section. This one, what do we want to do here? Maybe, substitution actually, because we can just, for this first equation up here, we can solve for z easily. We see that z is equal to minus 10y minus 19. All we do is subtract the 10y over. And then what we can do then is plug this into our second one. So what we're going to get is 3y plus 3 minus 10y minus 19 is equal to minus 3. So 3y minus 30y, 30 plus 1 minus 20 or 50, or what is it? 57 is equal to minus 3. So this doesn't seem right. I think we made a mistake. I need a calculator real quick. Sorry, and I'm pretty sure I made a little error somewhere in here. Let's try to find it. Let's see. So did we copy the problem down right? Okay, copy the problem down right. So we do the first step right. 6, 6, 6, 12, and 6 minus 4, 5, 31. All right, that 10. Okay, so I believe that's right. Now what happened in the second step? So we had 5, 5, 5, and 10, 5, 2, 2, 13, 3, 3, minus 3. It seems okay. Okay, so z is equal to minus 10 minus 19. 3y and 3 is a minus 10 minus 19. 3y. What's going on here? Oh, no, we're actually okay. Sorry. Okay, so then here we have 3y minus 30y, which is minus 27y. And now we need to add this 57 to the other side. So what we are going to have is then 54. And then we're going to divide by the 27 over, so we're going to get y is equal to minus 2. So no mistakes made, we're okay. So we found what y is minus 2. But now notice that, so we have these equations up here. Let's just take the first equation. 10y plus z is equal to minus 19. And now let's plug y into this equation. So what we get is 10 times minus 2 plus z is equal to minus 19. So minus 20 plus z is equal to minus 19. Add the 20 over, we get z is equal to 1. So now we know what y and z are. But look at this first equation, just right here, equation number 1 at the top of the page. X plus y plus z is equal to 2. X plus y plus z is equal to 2. Now what we can do is we can plug this y and this z into here. And so what we're going to get is x, so plus y, so plus minus 2, plus z, which is 1, is equal to 2. So x minus 2 plus 1 is equal to 2. X minus 1 is equal to 2. X is equal to 3. So we get our answers are x is 3, y is minus 2, and z is going to be 1. All right, let's do another one together. Let's do number 2. So number 2, we have x plus 6y is equal to 3, or sorry, plus 3z is equal to 4. And then we have 2x plus y plus z is equal to 3. 2z. 2x plus 2x plus y plus 2z is equal to 3. And then 3x minus y. No, sorry, 3x minus 2y. 3x minus 2y plus z is equal to 0. Okay, so let's do that same thing we did in the previous section. Let's get rid of the x's first. So what we could do is let's start by working with just equation 1 and equation 2, and then after, just like before, then we'll do equation 1 and equation 3. So notice with equation 1, we have a 1 in front of our x, and we have a 2 in front of this x. So let's take 2 and multiply it by equation 1, and then let's just rewrite equation 2. So 2 times equation 1, we're going to have 2x, then 12y, then 6z, and then 8. And then just equation 2, 2x plus y plus 2z is equal to 3. So now if we subtract these two equations, so 2x minus 2x is 0, 12 minus y is 11y, 6z minus 2z is 4z, and then 8 minus 3 is 5. All right. So we have one equation with just y and z now. So now let's do the same thing with equation 1 and 3. So now we have a 3 in front of our x. So we're going to want to multiply the first equation by 3. So we have 3 times this first equation, and then we'll just rewrite equation number 3. So we're going to have, for the first equation, 3x plus 18y, 9z is 12. And then the third equation, which is just 3x minus 2y plus z is equal to 0. Now let's subtract these two. So 3x minus 3x is 0. 18 minus a negative 2, so that's 20y. 9 minus z, so 8z. And then just 12. So now we have these two new equations that just have y and z. So now let's just work with these two equations. Let's work by solving this problem now. So now we just want to solve this problem. So notice, well, so we need to figure out how do we solve for y and z. Well, notice how that we have a 4 in front of this z and an 8 in front of this z. So if we multiply this by 2, it would match the other equation. So let's do that. Let's take 2 of this first equation. And then just rewrite the second equation. Okay, so what does this give us? Well, 2 times the first equation, we'll have 22y, 8z is 10, and then the bottom one will have 20y, 8z is 12. Subtract the 2. So 22 minus 20 is just going to be 2y. Now we have 8z minus 8z, that goes away. And 10 minus 12 is minus 2. So here we see that y is equal to minus 1. Okay, So now what we can do is we take either of these two equations, just like before, and we plug now y is minus 1 into them. Let's just take the top equation. 11y plus 4z is equal to 5. And now let's plug y is equal to minus 1 in here. So we're going to get minus 11 plus 4z is equal to 5. Okay, so we can add the 11 over, so we get 4z is equal to 16. Z is equal to 4. So now we know what y is, now we know what z is. So we could take any of our first equations. Let's take the first equation, the x plus 6y plus 3z. What was it? X plus 6y plus 3z is equal to 4. And now what we can do is we could plug z in here and we could plug y into here. So we're going to get x plus 6 times minus 1 plus 3 times 4 is equal to 4. Is that correct? Equal to 4. Yep. So we have x minus 6 plus 12 is equal to 4. So x plus 6 is equal to 4. X is equal to minus 2. So our answers are x is equal to minus 2, y is equal to minus 1, and z is equal to 4. Okay, how about one more together? Let's do 13z. Or sorry, let's just do 13. 13 is 2x plus z is equal to 1. And then we have 3y minus 2z is equal to 6. And then we have x minus 2y is equal to minus 9. So to copy everything correctly, so 2x and z, 3y minus 2z, and then x minus 2y minus 9. Okay. The first step here, which is going to be helpful, is to write this problem using x, y's, and z's. So we need like some placeholders. What I mean by that is, so this first equation, let's write it like this. 2x plus 0y plus z is equal to 1. For the next one, we'll have 0x plus 3y minus 2z is equal to 6. And the last one, we have x minus 2y plus 0z is equal to minus 9. So it's still the same thing. We're just putting in those like zeros as placeholders. And so now we still want to do that same thing. We want to figure out how can we get an equation that, so we just got to figure out how to get an equation with two variables and solve for that. So let's think. One thing that we can do here is let's take the first equation. Let's label these. Equation 1, 2, 3. So we can combine equations 1 and 2 or 1 and 3 together to get rid of the x's. So notice that we have a 2 in front of this x and a 1 in front of this x. So let's just rewrite equation 1, and now let's multiply 2 times equation 3. So then we'll have the same number in front of the x's. So equation 1 is just 2x plus 0y plus z is equal to 1. And then 2 times equation 3 is 2x minus 4y plus 0z is equal to minus 18. So just multiplying equation 3 by 2. So now what we can do is subtract these two equations. So 2x minus 2x goes away. 0y minus a negative 4y, so it's positive 4y. Z minus 0z, so it's plus z. And then 1 minus a negative 18, so 1 plus 18 is 19. So now we have an equation with just y and z in it. But notice that we have two of those. Here's an equation with just y and z in it, and here's an equation with just y and z in it. So let's just take both of those equations and then solve for y and z. So we have 3y minus 2z is equal to 6. 4y plus z is equal to 19. So now let's just solve this problem. This one's easy through substitution. We can just substitute. So for this bottom equation right here, we see that z is just equal to minus 4y plus 19, just from subtracting the 4y over. So then what we can do is we could take this equation and plug it into the top one. So we get 3y minus 2, so minus 4y plus 19 is equal to 6. 3y plus 8y minus 19 times 2, 36 or 38. 38 minus 38 is equal to 6. So we get 11y is equal to, so 6, add that over, we get 6 plus 38, which is 44. And then divide by the 11, we get y is equal to 11, or y is equal to 4. So we get y is equal to 4. And then what we do is we take either one of these equations and plug y is equal to 4 into them. So let's just take that top equation, 3y minus 2z is equal to 6. Plug y is equal to 4 into here. We're going to get 12 minus 2z is equal to 6, which is minus 2z is equal to minus 6, and z is equal to 3. Okay, and then we go back to the original problem. We found z is equal to 3. Let's just take this equation up here, this 2x, because we need to find x now. So we have 2x plus z is equal to 1. So 2x plus z is equal to 1. And then what we can do is we just plug the z into here. So we get 2x plus 3 is equal to 1. So 2x is equal to minus 2. And then x is equal to minus 1. All right, so then we get these three answers. X is equal to minus 1, y is equal to 4, and then z is equal to 3. Okay, I think it's a good place to end it. So that takes care of all. Oh, also, once the class is up, I'll write the homework for this section as well and post it online. It'll be up online like in an hour. Okay, yeah, but I think it's a good place to end for the day. So I'll see you guys tomorrow for the next video. Thank you, and yeah, have a good day. See you.